Okay, so today we start with software quality management. Now, this is something which you might have seen in software engineering also. So, what are the quality attributes and what do we look upon as quality management system? Now, software quality. Now, unlike other industries, quality in software is a huge challenge, right? Because requirements keep changing, designs keep changing in between, and we don't have that much of time to spend on maintaining quality, etc., etc. So all these are factors which pose us a challenge to deliver a good quality software. Unlike in the earlier period, when you have sufficient time to develop a product and release it into the market after doing substantial amount of testing, uh, trying out in various places, going live at different places, and then finally making sure that your product is working properly and efficiently. There are so many factors that contribute to the quality of a software, right? So all these factors to sync with each other is the most challenging part for a software organization, development organization. Now, first let us try to define what software quality is. Quality is actually fitness for purpose. Does it require, does it solve your problem and in an efficient manner, right? That's why we say fitness for purpose. It should solve the problem in an effective and efficient manner without any issues in between. Quality, by simple definition, is meeting its stated specification for its intended customers or meeting documented or undocumented customer requirements, which you call fitness for purpose. So by simple definition, it is meeting its stated specification for its intended customers or meeting documented/undocumented customer requirements, fitness for purpose. Now, this is problematic for software systems. There is a tension between customer quality requirement, which is efficiency, reliability, etc., and the developer quality requirement, maintainability, reusability, etc. Now, these are some factors which you have to keep in mind while talking about software. Now, one is from the customer's point of view, he looks at efficiency and reliability, etc. And from a developer point of view, he is looking at factors like maintainability of the software, reusability of the software. Now, remember, this is one challenging task, right? Because when you talk about efficiency and then maintainability also, then it becomes a huge task. That means on one side, it should be efficient. At the same time, it should be flexible enough to accommodate changes in the future so that you can maintain the software properly. The other one is reliability. Your software should be reliable. At the same time, you should develop components which can be reused at different places. So again, that there also there is a small what you call tie, that is maintaining a balance between reliability of the software and reusability of the software, because reusability demands a very modular approach to development, wherein each task can be broken down into one specific job only. At the same time, when you develop these kind of things, the question comes on reliability factor. How reliable is the whole software system? Now, some quality requirements are difficult to specify in an unambiguous way. So most of the software requirements might have uh, double meanings, in the sense it would convey something and it could also have another deep meaning inside it. The software specifications are usually incomplete and often inconsistent also. So whenever you go and try to understand the software and develop a document called software specs, most of the time it is incomplete because the customer might not be able to convey his exact requirement to you. So that poses a challenge. And then inconsistent. That means there might be changes requested very frequently. making it inconsistent. The focus may be fitness for purpose rather than specification conformance. Now, that is where we look at fitness for purpose. How good is the software functionally? We are not looking at anything else rather than specification conformance. Now, fitness for purpose means have programming and documentation standards being followed in the development process? Has the software been properly tested? Is the software sufficiently dependable to be put into use? Is the performance of the software acceptable for normal use? Is the software usable? Is the software well structured and understandable? Some questions that needs to be answered to understand the concept of fitness for purpose. One is having programming and documentation standards being followed in the development process. Second is, has the software been properly tested? Third is the software sufficiently dependable to be put into use? Next is the performance of the software acceptable for normal use? Next is the software usable? Basically, whether it is functional or not. Is the software well structured and understandable? Now, software quality. Now, proven software engineering practices, robust project management approach, comprehensive quality control, and quality assurance infrastructure. Now, these are the four factors that contribute to software quality. One is you must have proper proven software engineering practices. Now, software engineering is something like infrastructure itself. There are no standard rules, there are only suggestions as to how you can go about it. So, you, over a period of time with experience, should be able to develop a complete software engineering process of your own, fit for the organization, fit for the way you are functioning, right? Then robust project management approach. Quality cannot be implemented unless and until you have got a proper project management methodology in the organization, where you can insert controls at the appropriate places to ensure that things are going as per plan. Then comprehensive quality control. In every stage of development, you should be able to have what you call a quality control measure, wherein you make sure that only if the required quality is what you call conform to, does it go to the next stage. So at each stage, probably you should have a quality check, which makes sure that what you have been doing till now is as per the requirement and as per the quality checks. From where it slowly moves on to the next stage. And finally, quality assurance infrastructure. That is, you have an infrastructure which makes sure that whatever you do and whatever needs to be done can be handled in the infrastructure part. Different views of on quality. One is the transcendental view, something you recognize but cannot define, right? Then the user view, product meeting end user goals. Then three, the manufacturer's view, conformance to specification. The product view, meeting inherent characteristics, functions and features. Then five, the value driven, how much customer is willing to pay for it, right? So how do you go about defining quantity? One is the transcendental view, where you cannot define but understand what is that you want. Then does the product meet the end user goals? That's the next thing. Then conformance to the specification. Does the software development process conform to all the requirements of the software? Then the product view, right? Meeting inherent characteristics. Now, every product will have some kind of features and functions that are to be a part of the software. So does it meet that requirement? Then the value driven, how much customer is willing to pay for it. Now that also contributes to the quality, because the more the customer is willing to pay for a product, the better quality you will be able to deliver. Or rather, you should have a policy where if you're charging the customer high, definitely you have to take care of quality at that level itself. We know in the market there are expensive products supposedly uh, to be driven by quality, right? Okay. Now, Garvin's 8 dimensions on quality. One is performance quality, feature quality. So one is performance quality, how fast, how efficiently the program is running, quality on that. Then feature quality, that the what you call the quality of the features that are provided. Does it meet the customer's requirement? Along with that, does it uh, take care of some areas which were probably not even thought about by the customer, right? And it's completely reliable even then. Then comes the next point, reliability. Are you safe? Do you feel safe using the software? Right? Even if there is one bug in the software, that could be a reason why people keep away from the product because they don't know. Since one error is there, then they will always have a doubt that will there be more? That is another big challenge faced by organizations. So now see, for example, in a banking transaction, there are millions of transactions happening every hour. For the last 1 week, there was one single error that popped up, one mistake. Now, of the so many billion transactions that happened, one that means if you look at the rate of error, it is negligible. You don't even have to think about it, you don't even have to consider it. But the moment that transaction happened, the customer who suffered the transaction error will definitely will have his own apprehensions about using the software. And nowadays, with the social media, these kind of things spread very fast. So the damage is even more. So that is where reliability comes. It may be one small error, but if it questions the reliability of the software, then definitely you cannot say you are quality conscious. That means you are talking about something like 100% quality. Right? Okay. Then durability. How long the software is durable. Serviceability. Can you service the product without making big chaos of the software? Many times what happens is when you start modifying a software or maintaining a software, you start seeing new errors popping up. When you make one correction, you see another two errors popping up. That is primarily because of the design aspect of the software. So you should design the software properly. Simple things like use of variable names. There should be a standard methodology of using variable names. Not that each person who is developing a small piece of code will have his own naming convention. He will give the field name like as per his preferences. Now, when everybody does that, what happens is you don't have any clue about what field name is representing or what data name is representing what. Whether it's an internal variable, whether it's an external variable, whether it's a database variable, right? Whether it's a public variable, whether it's a private variable. So there are methods followed by companies where looking at the variable name, you know whether it is coming from a database or whether it's a public variable or whether it's a private variable or whether it's a local variable existing only in this particular function. So these kind of things have to be looked into. So if you do all that properly, then coding, you must have a structured standard approach for coding. Though we talk about coding in the way we like, but still, if you want to make it serviceable in the future, like for example, uh, imagine you are building a huge flat residential complex of around 200 flats, right? Now, imagine the wiring people and plumbing people do things like they want. What will happen? Tomorrow, when somebody comes, say 5 years down the line, when complaints start popping up, there will be nobody who knows exactly what is happening where. So what they'll do, they will solve the problem, but that might lead to another problem popping up somewhere else because you have not understood the complete structure of how this has been designed. So that is the reason why now when the building is designed, along with that plumbing, wiring, everything is actually documented. That helps serviceability. Otherwise, it is very difficult to carry out the service. Then aesthetics, the appearance, etc. Then perception, what the user feels, what the user wants. Does it deliver that? And then conformance to standards, and other requirements. Does the software meet the requirements of the user, and does it conform to the various external factors that are associated with the use of the software? Now, quality attributes as per ISO 9126. Okay, so 6 quality attributes as per ISO 9126. One is functionality, reliability. Functionality basically refers to the degree to which the software satisfies stated needs. Reliability, the amount of time that the software is available for use. Usability, the degree to which the software is easy to use. Then efficiency, the degree to which the software makes optimal use of the system resources. Then maintainability, the ease with which repair may be made to the software. And 6, the ease with which the software can be transposed from one environment to the other. So these are some of the key functions of the one is functionality, reliability, usability, then efficiency, maintainability, and finally portability. Now, software quality attribute definition part of it. A quality attribute is a measurable or testable property of a system that is used to indicate how well the system satisfies the needs of its stakeholders. You can think of a quality attribute as measuring the goodness of a product along some dimension of interest to a stakeholder. 1. Availability. 2. Interoperability. 3. Modifiability. 4. Performance. 5. Security. 6. Testability. Usability. Scalability. Portability. Mobility. And reliability. You can see all the areas are covered in these factors given here. Right? Availability, interoperability, modifiability, performance, security, testing, usability, scalability, portability, mobility, reliability, and so on. Then one is availability, 24 hours a day and 365 days a year. It's a factor which reflects the availability of the product. That means the product is reliable enough to run continuously without any issues. And if at all some issue comes up, the system takes care of it automatically. Fault versus error versus failure. Now trying to understand the difference. Availability is the readiness of the software to carry out its task. So how long a software is available basically tells you how long it is functioning. Fault, a condition that causes a failure, a wrong program code. Error, a difference between actual output versus expected output. Example, wrong code causing 4 plus 3 as 6. So error basically refers to what is the actual output and what actually the expected output had to be. Failure, inability of the system to perform a required function. Example, wrong financial report. It is not able to perform that or create that particular report. The primary objective of availability attribute is to remove faults with serious consequences. The secondary objective is to remove faults encountered most often by the users. Remember that not all faults are required to be removed. Now, availability and definition. Availability refers to the ability of a system to mask or repair faults, such that the cumulative service outage period does not exceed a required value over a specified interval of time. In hardware systems, availability is measured as MTBF, mean time between failures, the time between failures, and then MTBF plus MTTR, that is mean time to repair. Because once something fails, the recovery time will actually be mean time between failure plus mean time taken to repair. By how much time does it get back to normal? In software world, it is about what will make your system fail, how likely that is to occur, the probability, and that there will be some time required to repair it, which is called the mean time to repair. Now, availability is seen as a percentage uptime. System type, normal workstation, availability is 99%, 3.6 days downtime. High availability system, 99.9%, 8.5 hours. Fault resilient system, 99.99, downtime in a year is 1 hour. Fault tolerant system, 99.999, most available, most critical, and downtime in a year cannot be more than 5 minutes. So this is how you decide upon the quality of availability. Then comes reliability. Reliability is the ability to continuously provide service without failure, measured in terms of MTBF over a period of time. So the first thing as an architect, one must identify all SPOF, that is single point of failures, introduce redundancy both in hardware and software system to improve availability and reliability. So the first thing as an architect, one must identify single point of failures, introduce redundancy both in hardware and software to improve availability and reliability. What do you mean by that redundant? See, understand at what points the system fails and then have duplicate systems. Say, for example, if it is a server, have a mirrored server. If it is a hard disk, have a mirror hard disk. So that even if one system fails, that means you are having two servers running simultaneously doing the same task. So even if one is down, the other one automatically takes over and the user is not at all aware. So for him, the system is completely reliable. Depending on the complexity of your system, you can have that many resources duplicate. Right? Of course, with the coming of cloud, things have bettered in a huge way, but still there are issues which have to be taken care of specifically just to make sure that things don't happen. Right? General scenario, source of stimulus, internal and external people, hardware, software, physical infrastructure, physical environment. These are all source of stimulus. Now, stimulus, a fault of any one of the following class can occur. One is omission. A component fails to respond to an input. Crash. A component repeatedly suffers omission faults. Incorrect timing. A component responds, but response is too early or late. Incorrect response. A component responds with an incorrect value. Environment. The stimulus occurs under certain conditions. The system may be in overload condition or in normal operation or some other relevant state. Artifact. Which source is required to be highly available? Processors, communication channels, persistent storage, processes. Response. Prevent the fault from becoming a failure. So prevent a fault from becoming a failure. Detect the fault, log the fault, notify appropriate entities, people or systems, then recover from the fault. Disable sources of events causing the fault. So this is something which we can do just to make sure that the system is running properly. Be temporarily unavailable while repair is being effected. Fix or mask the fault or failure or contain the damage it causes. then operate in a degraded mode while repair is being effected. Now, response measure. Availability percentage, example 99.999%. Time to detect the fault, time to repair, and the time or time interval in which system can be in degraded mode, proportion, etc. Availability tactics. One minute. Okay, so availability tactics. Now, how do you make sure that the system is available? One is on the occurrence of the fault and fault masked or repair made. So these are the processes how you convert a fault into masking a fault or correcting the mistake. One is detect the fault, ping or echo, monitor, heartbeat, timestamp, sanity checking, condition monitoring, voting, exception detection, self-test. Recover from faults. 2. Preparation and repair, reintroduction. Preparation repair, you have active redundancy, passive redundancy, spare, exception handling, rollback, software upgrade, retry, ignore faulty behavior, degradation, reconfiguration. In reintroduction, you have shadow, state resynchronization, escalating restart, non-stop forwarding. Then comes personal faults. Removal from service, transaction, predictive model, exception prevention, increase competence set. Now, ISO 9001 standards, the quality management system. This standard can be applied to any industry, including software development, as it is very generic in nature. The emphasis is on defining and improving the process. Now, main clauses of ISO 9001-2015. Scope. normative reference, terms and definition, context of the organization, leadership, planning, support, operation, performance valuation, improvement. All these points are self-explanatory, so I don't want to explain it again. So scope of the project, normative reference, terms and definition, context of the organization, leadership, improvement, performance valuation, operation, support, and planning. Now, the 7 principles of ISO. One is customer focus. So the focus should always be the customer. Leadership, right? Then engagement of people, process approach, improvement, evidence-based decision making, relationship management finally. So these are the 7 principles of ISO 9001. Basically helping you out to carry quality management effectively. Now, Deming's PDCA cycle, plan, do, check, and act, right? Under planning, context of the organization, leadership, planning. Under do, support, operation, check, performance evaluation, act, improvement. So under context of the organization, understanding the organization and its context, understanding the needs and expectations of the interested parties, then determining the scope of the QMS, quality management system and its process. Then under leadership and commitment, which is very critical. Then you have the quality policy, organizational roles, responsibilities, and authorities. Planning, actions to address risks and opportunities, quality objectives and planning to achieve them, planning of changes. Then support, resources, competence, awareness, communication, documented information. Then clause 8, operation. Operational planning and control. Requirements for products and services, design and development of products and services, control of externally provided processes, products and services, production and service provision, release of products and services, control of non-conformity products. Then clause 9, performance evaluation. Monitoring, measurement, analysis and evaluation, internal audit, management review. Improvement, general, non-conformity and corrective actions, continual improvement. With so many points, it's difficult to explain each one of them, but I think most of the headings here are self-explanatory. Now, mandated documentary procedures. One is controls for document, controls of records, internal audit, control of non-conforming product, corrective action, preventive action. So one documented quality policy as a top management commitment. 2. Procedure for control of documents. 3. Procedure for control of records. 4. Procedure for internal audits. 5. Procedure for control of non-conforming products. 6. Procedure for corrective action. 7. Procedure for preventive action. Quality Apex Manual, the quality book. The TOC of a Quality Apex Manual is shown here. Table of contents. So you can see the table of contents here, what all a quality manual normally contains. Then comes quality policy. To continuously endeavor in our chosen business areas to be supplier of choice for our customers by meeting their requirements and expectations consistently, achieving excellence in execution and by deploying best practices, business process, tools, and methodologies, stimulating employees to learn and to grow in a challenging work environment. Quality manual. So this is how they actually implement quality in their system. It's kind of a flow chart which tells you about various aspects of the project: feasible, non-feasible, customer, communicate to the customer, then technical commercial proposal sign off, contractual agreement sign off, project kickoff and initiation, and then finally requirement study. Test cases, test conditions, each and every stage of the development process has been flowcharted here. Now, every section of QM must cross refer policies and procedures, control of monitoring and measuring devices, the clocks of all relevant information processing systems within ThinkSoft security domain are synchronized with Asia NTP server in.pool.ntp.org. The NTP pool is a dynamic collection of network computers that volunteer to provide high accurate time via the network, the time protocol to clients worldwide. The machines that are in the pool are a part of the pool.ntp.org domain, as well as several subdomains. And the documents referred to are HR policies, network management policies, policy test data, general management, process model delivery process change review, then technical purchase, resource allocation. Organization could decide the type of documentation required specific to their requirements. One is the vision, the policy, objective, process workflow, procedures, standards, instructions, templates, and checklists. So just a list of documentation required for specific to that. Not explaining all these charts. These are just given for reference so that you understand what documentation related to that is. Now, software quality management or quality management system summary. QMS defines a process framework for quality at organizational level, process, product, and project level. There are several standards frameworks such as ISO 9001, CMMI, ITIL for quality management in the development of software products and delivery, service delivery. Metrics are integral to any quality management process. Then process and project metrics are quantitative measures to gain insight into the efficiency of the software process and the projects conducted using the process framework. Then product and service metrics primarily focus on product attributes and service level agreements called SLAs. Now, software metrics, establishing a metrics program as a part of QMS. Now, software metrics, what we don't measure, we can't change, can manage. So everywhere there should be a quantitative aspect of rating or understanding the level of performance that you are delivering. The IEEE standard glossary of software engineering terminology defines a metric as a quantitative measure of the degree to which a system, component, or process possesses a given attribute. A measure is a number or a quantity that records a directly observable value of performance. Example, percentage of likes in Facebook. Now, metrics represent the different methods we employ to understand change over time across a dimension of across a number of dimensions or criteria. An indicator is a qualitative or quantitative factor or variable that provides a simple and reliable means to express achievement and the attainment of a goal or the results stemming from a specific change. Example, 1 million weekly active users. Now here again the measurement principle, formulate, define measures and metrics, then collect, decide the process of collection of data, then analyze, conceptualize and mathematical tools, then interpret, evaluation and gaining insights, and finally the feedback. So first is formulate, define, measure the and create the matrix. that what are the factors that you're going to use to quantify the progress of your project, then collect the data related to that, analyze it, then interpret it, convert it into what if meaningful statements, and finally the feedback part of it. Goal oriented measurement technique. GQM, goal, question, measure. Establish an explicit measurement goal specific to process or product. Define set of questions to be answered to achieve the goal. 3. Identify well-formulated metrics that help to answer these questions. Attributes of an effective metrics. 1. Simple and computable. 2. Empirically and intuitively persuasive. 3. Consistent and objective. 4. Consistent in its use of units and dimensions. 5. Programming language independent. 6. An effective mechanism for higher quality feedback. Now, these are the attributes that you have to look at. Simple and computable, empirically and intuitively persuasive, consistent and objective, consistent in its use of units and dimensions, then programming language independent, and effective mechanism for high quality feedback. Now, metrics for requirement specification quality. Characteristics versus metrics. One is specificity, lack of ambiguity. That means things should be very crisp and clear. There should not be double meaning statements. It should be complete in itself, correct. Understandability is very critical. People have to understand what you intend to deliver. Then verifiability, fifth point. Sixth point is internal and external consistency, right? Seventh is achievability. Eighth is concision. 9 is traceability. 10 is modifiability. 11 is precision. 12 is reusability. So percentage of requirements is a sum of functional and non-functional requirements. Q1, specificity. Ratio between ratio between 1 minute. Q1 specificity, ratio between count of requirements for which all reviewers have identical interpretation and total requirements. The Q1 value closer to 1 is an indication of lower ambiguity. Now, this is not closer, actually, closer, nearby. The completeness of functional requirement can be measured using Q2 is equal to NU by NI into NS, whereas NU is unique requirements, NI is the number of inputs, and NS is the number of states. Now, overall completeness Q3, NC, total number of validated requirements, and NV, total hash for non-validated requirements. Now, structural complexity. Structural complexity for hierarchical architecture call return of a module I is defined as S of I is equal to F2 out I, where F out I is a fan out of module I. Fan out is defined as the number of modules immediately subordinate to module I. That is the number of modules that are directly invoked by module I. So you look at one module and the modules coming under that, immediately coming under that. Now, data complexity. Data complexity provides an indication of the complexity in the internal interface for a module I and is defined as where V of I is the number of input and output variables that are passed to and from module I. System complexity. System complexity is defined as the sum of structural and data complexity specified as C of I is equal to S of I plus D of I. Now, metrics of program source code. One is the program length, volume for an algorithm. These are all measurement areas, right, which you use for understanding the volume of the project or the size of the project. So each and every aspect has to be looked into. So volume for an algorithm, number of bits to specify the program complexity, then language level, development effort, development time, projected number of faults, right? All these are various areas that has to be looked into. That is source code metrics. That is metrics related to the source code. One is the program length, volume for an algorithm, number of bits to specify the program complexity, language level, development effort, development time, and projected number of faults. Metrics for testing effort, PL, program level, V, program volume, PL is equal to 1 by N1 by 2 into N2 by N2. E is equal to V by PL. The percentage of overall testing effort can be allocated to a module K. Percentage of testing effort K is equal to E of K divided by sigma E of I. Now, metrics for object-oriented testing. Lack of cohesion in methods, percentage public and protected, public access to data members, number of root classes, fan-in, number of children NOC, depth of the interface tree, called DIT. Now, software maturity index. A software maturity index that provides an indication of the stability of a software product based on changes that occur in each release of the product. The following information is determined. So, how do you decide upon how the software becomes mature? Is primarily the number of changes that are required in or occur in each release of the product has to reduce. The lesser number of changes, that means the more mature the product has become. The following information is determined. MT, number of modules in the current release. FC, number of modules in the current release that have been changed. FA, number of modules in the current release that have been added. FD, number of modules from the preceding release that are deleted in the current release. SMI is equal to MT hyphen FA plus FC plus FD divided by FT. As SMI approaches 1, the product begins to stabilize. Now, defect removal efficiency, measurement of software quality. The quality metric that provides benefit for both the project and process level is defect removal efficiency. In essence, DRE is a measure of filtering ability of the quality assurance and control actions as they are applied throughout all processes framework activity. DRE is equal to E by E plus D, where E is the number of errors found before delivery and D is the number of defects found after delivery. So number of errors found before delivery divided by number of errors found before delivery. That means the total number of errors before delivery and after delivery. The ideal value of DRE is 1. That is, no defects are found in the software. Realistically, D will be greater than 0, but the value of DRE can still approach 1 as E increases for a given value of D. In fact, as E increases, it is likely that the final value of D will decrease. Measures across SDLC. Requirements, design, implementation, and testing. Completeness. All should be there. Number of conflicting requirements. During the requirements and design phase, yes. In the implementation and testing phase, no. Requirements traceability should be there only during the design phase. Defect indexes in all phases. Failure avoidance in design, implementation, and testing, where you cannot afford to make mistakes. Incorrect operation avoidance, DIT, design, implementation, and testing. Incorrect operation advance, all phases other than requirements. Maneuver per major defect detected, all phases other than requirements, count of entries per module in design and implementation, software measure science measures in implementation and testing, cyclomatic complexity, all stages other than requirements, and data flow complexity, all stages other than requirements. Then fault density in all stages, software maturity index in in design and testing, mean time between failure in testing, failure rate in testing, mean downtime in testing, defect density in all phases other than requirement, cumulative failure profile only in testing, cost and gap graphing, error distribution, faulty data numbers, test coverage in all stages, graph complexity, and so on and so forth. All these factors just come there. Now, software quality planning and quality metrics. Just give me a second. Okay, measuring quality. Metrics for software quality. Correctness. Number of defects per kilo lines of code. Where a defect is verified, lack of conformance to requirements. Right? Defects are those problems reported by a program user after the program is released for general use. Then comes maintainability. Ease with which a program can be corrected if an error is found, adapted in if the environment changes, or enhanced if the customer has changed requirements. Mean time to change. The time to analyze, design, implement, test, and distribute a change to all users. Maintainable programs on average have lower mean time to change. So correctness, maintainability, quality planning. Project planning is guided by a quality plan, right? Because when you plan a project, quality factors have to be incorporated into the project planning process itself. So that's why we say project plan is guided by the quality plan. How much quality you want to put into place decides upon how your project is going to be planned. A quality plan sets out the desired product qualities and how these are assessed and defined the most significant quality attributes. The quality plan should define the quality assessment process. It should set out which organizational standards should be applied and where necessary, define new standards to be used. Quality plan structure. Product introduction. Product plans, process descriptions, quality goals, risks and risk management. Quality plans should be short, succinct documents. If they are too long, no one will read them. Usually quality plan is prepared before project plan. One is the scope of plan, refers to other documents, quality management, including organization, tasks, and responsibilities. This is a lot of theory, which I know anybody can read and understand, but I will try to go through and then explain whatever needs explanation. So standards, checklists, practices, and conventions, reviews and audits, testing, problem reporting and corrective action, tools, techniques, and methodologies, code, media, and supplier control, records collection, maintenance and retention, training, and risk management. Quality planning aligns with the QMS framework adopted, quality management system framework, which is adopted. Software quality management SQM is concerned with ensuring that software has a low number of defects and that it reaches the required standards of maintainability, reliability, probability, and so on. SQM includes defining standards for processes and products and establishing processes to check that these standards have been followed. Software standards are important for quality assurance as they represent an identification of best practice. Quality management procedures may be documented in an organizational quality manual based on ISO 90001 model or CMMI framework or ITIL framework. Now, software project planning. Planning starts with estimating effort for different phases of the project. Once the size of the project is estimated using FPs and object points, we can convert the size into effort based on calibrated historical data. We can then distribute the total effort across different phases of the project, again based on historical data. For example, 7% is required for requirement gathering, 8% for requirement analysis, 20% for architecture and design, 50% for construction, 15% for system testing, 5% for project management. Note that all percentages are illustrative only. Actual percentages should be based on historical metrics data. Process related or other consideration. Configuration management 2 to 5% of technical effort. Requirement change 1 to 4% effort per elapsed month. First time development with new language and tool 20 to 40% effort. Contingency depending on risk severity and probability 5 to 10%. So here you have wonders upon the activity that you do, and here you have something based on the other considerations that you have to look into. Proposal, estimation of effort, pricing, terms, and project plan. Proposal planning for sharing with customer during pre-contract stage. Understanding of requirement, recommended approach, technical architecture, estimation of effort, person weeks, project plan, approach and high-level activities, business model pricing, terms and conditions. The project planning process. After the contract is approved, plan-driven development for agile planning, SP/Scrum. Project activities WBS, scheduling and resource planning, project organization, communication, escalation paths, quality planning, warranty, maintenance, and post delivery. Software pricing. Pricing is an art and science driven by business and relationships. Estimates are made to discover the cost to the developer of producing a software system, hardware, software, travel, training, and project management overheads, etc. So all these factors have to be considered while costing a hardware. No simple relationship between the development cost and the price charged to the customer. Broader organizational, economic, political, and business considerations influence the price charged. Market opportunity. A development organization may quote a low price because it wishes to move into a new market segment of the software market to establish new business relationship with a customer. So pricing can be low if you want to make an entry into the market. Then cost estimate uncertainty. If an organization is unsure of its cost estimate, it may increase its price by a contingency over and above its normal profit. Uncertainty due to change in requirements, terminology, etc. That means if you're not sure about how to go about the price, always leave a higher margin, contingency expense, what you call, and then do things accordingly. Then contractual terms. A customer may be willing to allow the developer to retain ownership of the software code and reuse it in its projects. The price charge may then be less than if the software source code is handed over to the customer. A customer may be willing to allow the developer to retain ownership of the source code and reuse it in other projects. The price charged may be less than if the software source code is handed over to the customer. Okay. Now, plan driven development. When there is not much uncertainty or requirements volatility. So, plan driven development is when you are sure that the project won't change much or the percentage of change will be negligible, and then requirements volatility. That means requirements also will not change. Plan driven or plan based development is an approach to software engineering where the development process is planned in detail. Plan driven development is based on engineering project management techniques and is the traditional way of managing large software development projects, waterfall, V process, incremental, etc. A project plan is created that records that works to be done, who will do it, and the development schedule and the work products ISO 9001 compliant SDLC. Managers use the plan to support project decision making and as a way of measuring progress. At every stage, extensive formal documentation may be required, ISO 9001. Agile methods, Scrum framework is adopted when there is requirement volatility and schedule cost constraints driven by time to market pressures, which is a reality today. So depending on the situation of the process involved in your product development, you can adopt the required measures so that you don't land up overspending or the project completely going out of control. Now, setting project goals or objectives. Goal or objective of a project versus metrics for performance measurement. Objective slash goal. Overarching objective slash mission versus metrics, product process project. Business strategic transformational. Then operational capability enhancement, schedule slash cost overruns, productivity, efficiency, etc. Defining success, answering the question, what do we have to do to have a success? Sets a project scope informally. The objective of a project can be defined by completing the statement. The project will be regarded as a success if that metrics focus on what will be put in place rather than how activities will be carried out. Metrics to be smart. S specific, M measurable, A achievable, R relevant, T time constraint. Now, these are some of the key areas that you have to look into. Specific should be measurable, achievable, relevant, and time constraint. Now, plan driven development. A typical project plan contains introduction, project organization, risk analysis, hardware and software resource requirement, work breakdown, project schedule, monitoring and communication, etc. Quality plan describes the quality procedures and standards that will be used in a project. Validation describes the approach, resources, and schedule used for system validation. Configuration management describes the configuration management procedures and structures to be used. Maintenance plan predicts the maintenance requirements, cost, and effort. Staff development plan describes how the skills and experience of the project team members will be developed. Project planning is an iterative process till the end of the project. The project planning slash execution process. Identify constraints, identify risks, define milestones and deliverables. Then define project schedule, system project planner, minor problems and slippages. Do the work, monitor the progress against plan once the schedule is defined. Then if no problems, project finished, otherwise unfinished, again go back, do the work, and it cycles. If there are problems, serious problems, initiate risk mitigation action and replan the project. So this is kind of a flowchart for project planning and execution process. Now, agile project planning. Now, one thing I would ask you to do is, can you see if the quiz is active or not? One of you, please check if the quiz is accessible to you. If the quiz is active, you can start answering the quiz. Okay. So please answer the quiz. Okay, those who have completed can leave.